Okay, welcome back to Project-Based Learning Part 2. For this section, I'd like to talk to you about the amusement park project that we did in class. So what we can do is click the top part here on the bar, and it'll take you to a different screen. My goal for this part is to share how I use project-based learning in my classroom and to provide others with example models that we could use that I learned through research and that I did practice with my classroom. I decided to develop a unit on motion using this model, project-based learning, and incorporate what research defines as good PBL design. I use 21st century ideas as to help incorporate technology as a component to help showcase student work. I use Google Classroom to help students interact with other students, reteach material, use videos and instructional videos, learning activities, and give students an opportunity to create videos to share their science projects. Below I have listed here a bunch of goals that I wanted the students to accomplish, and a couple of these I noticed that we struggled with, and basically what I did is I took a project that we were currently working on and I elaborated on it, and I added some key components to it to help process some of the more difficult standards that I recognized happened at the beginning of the school year. So maybe I can go back and reteach some of this stuff that we struggled with. For example, the position and speed graphs, students struggle with that. And I thought, how can I incorporate that within a project-based learning environment? So I took what we were currently working on and we basically developed this amusement park project idea where the students had an opportunity to basically choose between 3 different projects. And I could show you, this is the assignment that I gave the students, where I wanted the students to assume a career. So I wanted them to act out what it would be like to be an engineer. And we talked about engineering and what it actually means in science and so on. They were to choose one of the 3 different activities below. One was build a dragster, another would be a game, or the third one would be a roller coaster project, which would have been something that we currently were working on. So that's where I got some of these pictures here, because that's what they were doing. So to elaborate the dragster, I gave them a set of materials in a brown paper bag. In fact, I gave all groups a bag. And we collected like cereal boxes. I had parents donate cardboard. I bought a bunch of tape because it did require us to buy a bunch of tape. So that would be one hidden thing. In terms of materials, you could throw fun things in there too, like clay or other items. I gave them a big bag of just stuff. And the idea is that they sort through the materials and figure out for themselves how they can design one of these different activities. For the dragster, I did give them some kind of guidance. I wanted them to design a ride for an amusement park that would move at the fastest speed possible in 5 meters and create distance time graphs at the end to show the motion of the dragster, which that's where I tried to incorporate some of the more challenging learning objectives from earlier in the year that we taught. Now, I did not give them too many restraints on materials. In other words, they were allowed to use balloons, they could use rubber bands, they could bring materials from home, and this required them to do a little bit of research too, so they could go online and figure out what would be the best strategy to make that happen. And that was a pretty cool component for that. The second piece, they were allowed to choose one of the 3, so they could choose building a game. And we did use a lot of transferring energy from like sound energy to potential and kinetic. We talked about that, and how they can use that transfer of energy to make a hum sound and then a ding sound. And when they pull a lever, I gave them a motor for this activity as well. But they were allowed only to use the materials that I gave them in the bag. And the idea here is that they could design a game that would be found at an amusement park, and then try to incorporate the idea of energy transfer to communicate what they've learned. Then the third activity is to build a roller coaster. This was a really fun activity. We did this during class this year. I do hope to do this again next year, and then maybe make some changes and stuff from what we talked about this year. I'll talk about that here in a second. But we gave them, again, a big brown bag, and then in the bag they were to try to engineer a device that would move a marble up a slope. And so they had to do some research, try to figure out how they would get the marble to go up. I gave them a motor as well, the little engine motor that they could use, and then move the marble around a loop with an amusement park theme. So that would have been the main idea for that. I wanted them to have at least 4 meters of track. And I also wanted them to only have a limited amount of space. So they had just a poster board flat on the ground that they were to work on. And so in other words, it forced them to go up and try to make their roller coaster go up versus going out. And then to try to keep the marble at a constant, well, slow speed really, or to suspend off the ground as long as possible. So it required them to time the marble every meter, and then we tracked how far it went, and then also created a chart, a distance versus time chart, to move the marble, or to track the marble's motion. All students for all 3 of these projects were to present their projects to the class. I also wanted them to write a report to share their experiences. Some of the reports turned out to be like really detailed. It really incorporated writing into our science lesson and reading and research. And that piece was really good. I learned a lot about basically how they viewed this whole process. And it was a pretty good sharing experience. Then I wanted them to video the project. I had a few students that really took off with this part because they were really kind of obsessed with trying to find the perfect picture for when they would make the roller coaster go down, or the marble go down. Here's an example of one of the groups over here working on their roller coaster project. And you can see the little slope and then air drain into this little funnel and then down. I did give the students a few videos to watch before the project just to spur that interest. These here are pretty good videos that will capture the attention of a real life experience, and it will help bring the classwork to life. So I'm not going to play all of these for you, but this will give you some sense of what they watched. And you can see this one here is a roller coaster. Obviously that you can build the suspense by going up and then over the top. I'll click through some of the slides. But you can see that it kind of brings them into the reality of an actual roller coaster, so they feel like they're actually going to be designing this. You can see, I don't know about you, but I'm starting to feel a little nervous. And that's where I'll stop with this one. Then I also have another one here for a dragster video clip that I wanted the students to see so that they could get a sense of kind of like what we were talking about with the second project with building a dragster. And I wanted them to actually feel like they were part of the process as a real live engineer. I'll stop this too. Then I wanted to give them some clues and some ideas for the carnival games. And with this video, if they decided to choose that activity, this video will show different examples of what they could do. This was a really good example. I'll click down through just so you can see a few of them. And again, they had the same materials with cardboard, and they were to just try to design some kind of a game that would work at an amusement park. And our focus for that would have been transferring energy, kinetic energy, potential energy, and they had certain guidelines with that they had to follow. So here's some pretty good examples. Makes me want to go to a carnival. All right, so as I look down, there's other videos here that I did give the students after they work with the kind of these videos here actually show real works from students that actually did do the projects already. So I wanted to provide them with an example of what it could look like. Now, of course, this one's the ultimate paper roller coaster project. Yeah, that's pretty tall. And that took a long time for them to build, but I wanted to show them some examples of different things that they could do. And you could see from the first picture that I showed earlier that a lot of the students actually did use some of the same concepts. I did notice some people using this concept here, and I could just kind of scroll down through. We won't watch this entire video, but if you want to go to my site, you can watch the entire thing. It's pretty cool. There's some pretty cool things that we'll kind of highlight here. And you can see that it goes all the way down to the bottom. And they give pointers on basically some different things on how you could do this. Now, again, like right now, the marble is pretty much at the same point in distance. So they'd have to show this, that the marble's not moving in terms of distance on a distance versus line graph, which was kind of a cool process. Okay, I won't show any more of that one. That gives you a pretty good sense of basically what they had to accomplish for their task. And then the dragster one, I wanted to give them an example of how they could use some of the household materials to build and design. We called it a go-kart or a dragster. So for this one, I'm not going to play the entire thing, but I'll just show you the end. In this case, here's an example where they were able to get this to go 4 meters. And it will shoot clear across. It went pretty far. So that was a good example of what they could do. And of course, if they did some research, there's all kinds of different go-karts and cars that they could make out of balloon powered. So I gave them some freedom with how they can use energy to make the motion of the go-kart. That was pretty cool. The third video down here is another one about how they could build the games. And here's just some ideas on some of the games that they could build. This came from a 6th grade classroom. And this was a pretty cool video because it shows different examples that they could use. So I'll just kind of scroll through some of these just so you can get a sense of. This one, we actually had some students build that one. It was pretty cool. I had a student build one like this, and he was using wood, and it would actually stick in there, so I told them not to do this. So things like that will definitely need adult supervision for. So the assessment piece down here, students will be able to take ownership in their overall performance using the following assessment below. So I let them rate each other on a scale from 0 to 5, where 0 is not complete and 5 is excellent. And then I'm really focused on the 21st century skills that we talked about with communication, how do they work with their group, different things like just basically organization, that's a big piece, and so on. And then also it gave them a chance to tell me about what they feel and what they believe. Down here I have the directions for the report, some questions to steer them in the right direction. I also had them do a graphic organizer, and I let them choose the graphic organizer they would like to use for that. And the graphic organizers turned out really good. But some of the questions I did ask